Okay, we're doing absolute value inequalities, and so we are going to first start off with what we call compound inequalities. Now, compound inequality has an inequality happening twice. So there are two versions of this. There's the AND inequality, compound inequality, and you'll see this generally stated as, like I say, a 9, and then is less than 3x plus 6, which is less than, say, 15. When you have an AND inequality like this, and you have your variable in the center, what you have to do is you have to solve from the inside out. All right? So, rather than subtracting 6 from just one side, I have to subtract 6 from the 15 side, and I also have to subtract 6 from the 9 side. All right, because I'm solving from the inside out, so I just need to know 9 minus 6, that is 3, is less than 3x, which is less than 15 minus 6 is, in fact, 9. So now all I have to do is divide by 3 on all 3 counts. And I've got x is, and the way we say this is x is in between 1 and 3. All right, and that is my inequality. Now, instead of one critical number, I have 2. So I go ahead and draw my number line here. I'm going to draw a 1 right here and a 3 right here. What type of circles do I have? What type of circles do I have, Luke? Both open, and since x is in between them, does it make sense that the line would be in between the circles? Does that make sense? Kiyomi, you're good with that? All right, cool. Oops, sorry. Give you guys a second to copy that down. Let me give you guys a second here to do this problem. I'll give you guys this here. I'll call this example 2. Negative 16 is less than or equal to negative 9x plus 2, which is less than 56. I'm going to pause real quick, and I'll let you guys know there's a certain twist to this problem, and let's see if you guys can't figure it out. Okay. We're all good with subtracting 2, right? So I got negative 18, negative 9x, and 54. Now, when I divide by negative 9 here, Jared, what's going to happen when I divide by negative 9?
You have to flip the inequality sign.
Flip all the inequality signs, right? So this is going to be negative 6, and this is going to be positive 2. Now, this is where things might get a little bit confusing. What number goes on the left? What number goes on the right? What goes on the left? Joshua? The negative 6, right? Because that's less. And then the 2. And now, what type of circles do I have? What type of circles do I have? Brian? Open at negative 6, closed at 2. And we're in between. Raise your hands if you got that right. Nice. Nice job. Serena, how you doing over there? Doing good? Ran into that cousin of yours yesterday. Yeah. Hey, Robert, what brings you back?
I just had a stomach ache for a little bit, but now it's good.
Okay, good. Glad you could join us, buddy. All right. The other type of inequality is what we call the OR inequality, where you might get a problem, and OR inequalities are actually pretty straightforward. It's x minus 3 equals 1, or x plus 1 is less than 1. The way you do this is it's pretty simple. You just solve each, that's awful, each individually. Okay, just solve each one individually. So here, we're just going to add 3 to both sides. X is greater than 4, or x is, sorry, if I subtract 1, x is going to be less than 0. So now when I graph that, My two critical numbers are 0 and 4. I've got two open circles. If x is greater than 4, which way am I going? Aaron? Right. If x is less than 0, which way am I going? Eric? Left. Do you guys remember this from Algebra 1, 2 over at Mesa Verde or Black Mountain? The or kind of outside and kind of inside? Yeah. You like that, Justin? Was that funny? Oh, okay. Yeah. All right. Sweet. Okay. Okay, questions on compound inequalities. Because that's compound, when we get to absolute value, it kind of combines the two skills together. Okay, remember absolute value. Make this heading. With all absolute value problems, remember, we always had a negative version of the problem and a positive version of the problem. So from here, the negative version of the problem is negative, parentheses, whatever was on the inside, right? So in this case, it's negative 2x. In this case, it's negative 2x is less than 6. On the right side, the positive case, it's going to be 2x is less than 6. I'm going to clean this up because we don't really need the parentheses there, do we? We don't need them, so negative 2x is less than 6. If I divide both sides by negative 2, whoops, x is greater than negative 3. Do we all see that? All see that? Good. If I divide by positive 2, x is less than 3. So on my graph, I'm at negative 3 and positive 3. I've got two open circles, and it looks like I'm greater than negative 3 and less than positive 3. So I have, what type of graph is this? And or? And. It's an and graph, right? And agrees with each other. That's why they're kind of locked in with each other, right? They agree. I'm sorry, by the way, that was number 28 from your assignment. Okay, number 30. Absolute value of 2x minus 9 is less than or equal to 27. Again, the negative version of this problem is negative, parentheses, 2x minus 9 is less than or equal to 27. The positive version of this problem is 2x minus 9 is less than or equal to 27. Questions so far? Amol, what's up?
What would happen if you did that thing where you like timed it again by -1?
Oh, like right here?
Yeah.
Okay, that's what we're gonna find out. You're starting to ruin the movie for me. Okay. What? I don't have the space, so let's go ahead and divide everything by -1. Amol, good question on a very serious level. If I divide or multiply both sides by -1, what do I need to do with my inequality symbol? Eric? Gotta flip that thing over. Boom, so it's -27. Does that answer your question, Amol? Good. So now I'm going to add 9 to both sides. 2x is greater than or equal to -27 plus 9 is -18. Divide both sides by 2, and I'm running out of space here, but that's okay. X is greater than or equal to -9. You guys go ahead and finish off the positive case. What is x less than or equal to? As soon as you got the answer, raise your hand, please. Mr. President. 18, thank you. So, we've got this graph right here, -9 and 18. They're both closed. See, it looks like we're less than 18 and we're greater than -9, boom. Did your teachers at Mesa Verde tell you what the trick was with these? Like how to identify whether they're and or? Less than is and. Less, that's why they call it less than for absolute value. Right? When you get something like, say, 42. Which is 5x minus 7. It's greater than 81. Let's go ahead and, actually, I'll give you guys a chance to do that one on your own. Oops. All right, everybody, let's not do that. We good? Okay, cool. All right, so we've got two versions of this problem, right? We got the negative version, which is negative parentheses 5x minus 7 is greater than 81. If I divide both sides by negative 1, I'm going to have to flip my inequality, so 5x minus 7 is less than negative 81. If I add 7 to both sides, 5x is less than negative 77. So x is less than negative 77 over 5. Raise your hands if you got that for your negative case. Negative 77 over 5. Oh, 74? I'm sorry. My bad. Thank you. It is negative 74. You're right. Okay. Positive version is 5x minus 7 is greater than 81. So we're going to add. Maddie, you see what you did to me? You should have left it at me thinking it was 77. Because now I'm all messed up. 88, right? Raise your hands if you got that. 88 over 5. Am I good? All right, good. Okay, so now we've got our number line here, negative 74 over 5 and 88 over 5. We've got two open circles. Now this time, 88 over 5 we're greater than, which means we're heading to the right side, yeah? Negative 74 over 5 we're less than, which means we're heading to the left. So this is what type of graph, an and or an or? Or. And the way you kind of quickly identify that is this is what we call great or. Okay? And then there's less than. It's kind of a gimmick to, I'm not big on gimmicks, but that one's actually kind of okay. Questions on this section? How are we all doing? Good? Okay, couple little ways that they can mess with you. If they give you the absolute value of x plus 3 plus 4 is greater than 0, before doing any absolute value equation, what do we need to do first? Maddie? Subtract 4 from both sides. You got to get those bars by themselves, right? So we've got absolute value of x plus 3 is greater than negative 4. Now, who can raise their hand and tell us in one maneuver what is the answer to this problem? Samantha. Got to be all real numbers, right? Because anything that I put inside of x is going to make it greater than 4. If I choose, even if I choose negative 5 million, right? Negative 5 million plus 3 is negative, 499, blah, 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 blah. But the absolute value of that really big negative number is positive, and that number is bigger than negative 4. Does that make sense? Amol, are you convinced? Okay. Now, be warned. I will warn you now. There is a difference between that problem and this problem. Same process. Who can raise their hand and tell us what is the answer to that problem? Javad. That's no solution. Why not? I mean, why? Sorry. Yeah, this still jumps out as positive, and yet it is greater than -4. We established that with this problem. However, this, and I'll even highlight this in Ketchup, this equal sign underneath makes it no solution because there's never a time where a positive number will equal a negative number. Does that make sense, everyone? So when there's an equal sign underneath, game over. It's going to be no solution. All right. When it's greater than, then it's going to be all real numbers. If it was less than, it would be no solution because it can't be, right? If I was to give you guys this problem, get my mustard back. Right? Which one would this be? All real numbers or no solution? Andres? No solution, right? Because, sorry, go ahead. Go ahead.
Because when there's no numbers that are equal, because the left side is positive and the right side is negative, and negative is never greater than positive.
Negative is never greater than positive. Perfect. Any questions on this section? Any questions? Okay.